Welcome to the deep dive. Today, we're really getting into something fundamental in construction, the specifications document.
Mhm.
We often focus on the blueprints, the drawings, right? But today, it's all about those written descriptions. We've got some great source material that digs into why they're so critical.
Absolutely. It's funny, you usually picture the drawings first, the shapes, the sizes.
Yeah.
And they are vital, no question.
Sure.
But our sources really drive home that drawings mostly tell you about quantity, how much stuff you need.
Yeah.
It's the specs that give you the quality.
Okay, let's unpack that. So drawings, quantity, specs, quality. Like, the drawings show how much concrete for a foundation, but
Exactly.
the specs tell you what kind of concrete. It's strength, the mix, that sort of thing.
Precisely. That's the key difference.
Yeah.
Think about, say, roofing.
Okay.
The drawings show the square footage, the area to be covered, but the specifications,
Yeah.
they're going to list the exact type of tile. The manufacturer, maybe even the product line, the color the architect picked out, the fire rating it needs, even how it has to be installed.
Without that written detail, it's just a roof shape. You don't know what it's made of, really.
You got it. Leaving that open, that's asking for trouble, or at least big cost questions later on.
Yeah, I can see that. It's like, the drawing shows a wire path, but the spec defines the wire itself, insulation, material, standards it needs to meet.
Perfect analogy.
Our sources also bring up something called the project manual, especially for bigger jobs. What's that about?
Yeah, on larger, more complex projects, you often get this compiled binder, the project manual. It's basically the central hub for all the key written documents.
So more than just the specs.
Yeah. It definitely includes the specifications we're talking about, but usually also the formal agreement, the owner-contractor contract,
Okay.
the conditions of the contract, general and supplementary ones, plus any changes or addenda that came up. It's the whole written story of the project, essentially.
Like a comprehensive rule book for the build, all in one place. Makes sense for complex stuff.
Definitely.
Okay, so let's get into the real meat of it. What exactly do these specifications identify? The sources say for tiny jobs, maybe a note on the drawing is enough, like for a specific faucet model.
Right, for something super simple, maybe. But as soon as you get any kind of complexity, that falls apart fast.
Like the roofing example again?
Exactly like the roofing example. The drawings show the what and where in terms of shape and size, but the specs deliver the critical how and with what.
So the specific tile maker.
Manufacturer, yeah.
Right.
The color code,
Yeah.
the performance standards it has to hit. Even, like our sources mentioned, the exact overlap for the underlayment, 2 inches side lap, 6 inches end lap. Stuff drawings just can't show effectively.
Those little details seem crucial. So beyond just naming a product, what are the main types of information we find in specs? Our sources break it down, really.
They highlight a few key things. First, obviously, is the quality of materials and products. And this gets specific. It defines attributes, properties. The example they gave was great. Standard weight extruded concrete roofing tiles, old world slate manufactured by Hansen, color selected by architect.
Yeah.
Very little wiggle room there.
Right, not just concrete tiles, but those specific ones. Okay, what else? There's quality assurance, or QA.
QA. That's all about how you make sure you get the quality you just specified. It outlines the procedures, maybe testing requirements, the standards you have to meet to avoid defects.
Like checks and balances?
Sort of, yeah. The source mentioned conforming to the NRCA Steep Roofing Manual. That's the National Roofing Contractors Association. Using established standards like that is common.
Got it. So state the quality, then state how you'll prove it. Makes sense. What's next?
Then you've got special installation requirements. Sometimes the architect or engineer wants something done a very specific way, maybe different from standard practice.
Like the underlayment laps you mentioned.
Exactly. Install underlayment with 2-inch side laps and 6-inch end laps. That's specific instruction. It might seem small, but it affects performance, durability. And the contractor needs to know that to price it and do it right.
Yeah, those details add up in time and cost, I bet. And the last one mentioned was submittals. What are those?
Submittals are basically proof the contractor needs to send back to the design team for approval before installation.
Okay, like homework.
Sort of. It ensures they've understood the specs and are planning to use the right stuff. It could be manufacturer's product data sheets, actual physical samples, like a couple of those roof tiles.
So you can see the color and texture.
Right. Or even shop drawings, which are detailed drawings showing exactly how something custom might be fabricated or put together.
So it's a check step. Verify before you build. Makes sense. Our sources also really stress the link between specs and cost estimates.
Oh, absolutely crucial. You cannot get an accurate cost estimate without the specs. period.
Because the drawings only give you the how much?
Exactly. Drawings tell you the quantities, square feet of wall, linear feet of pipe, whatever. But the specs tell you the quality.
Hmm.
Is it basic drywall or high impact resistant? Standard copper pipe or specialized stainless steel?
And the cost difference there could be huge.
Massive. Plus, those special installation requirements, they take time, maybe different skills. All that impacts cost. A bidder needs the specs to know what they're actually pricing.
Okay, crystal clear. Specs define the what and how well, which drives the cost of the how much from the drawings. All right, let's switch gears a bit. How is all this information actually, organized?
Specs are usually broken down into sections, right? Like for wood windows, concrete, etc.
That's the standard approach, yeah. It breaks the project down into logical chunks based on materials or systems. And within each section, the writer has different ways to actually define what's required. Our sources lay out 4 main methods.
Okay, 4 ways to spec something. What are they?
First up is descriptive. This is where you detail the properties, the characteristics, but you don't name a brand.
The example was about grout sand. Sand for grouting shall pass a 30-mesh screen. It just describes the physical requirement.
Got it. Focus on the what, not the who makes it. What's number 2?
Second is performance. Here you focus on the result, the outcome you need, not how it gets there, or the specific product.
So more about what it needs to do.
Exactly. The example was an exhaust fan specified by its capacity. Capacity of 500 CFM cubic feet per minute. How the fan achieves that. Less important than the fact that it does.
Right, that gives the contractor maybe some options to meet the performance target. Could be good for value engineering sometimes.
Potentially, yeah. Third is reference standard. This is where you lean on established industry standards.
Like the ASTM or NRCA you mentioned?
Precisely. Things like ASTM International. So for Portland cement, the spec might just say, conform to ASTM C150. It relies on that published standard to define the baseline quality and characteristics, saves writing it all out.
Okay, leveraging existing benchmarks. Smart. And the last one.
The fourth is proprietary. This is the opposite of descriptive, really. Here you name names.
A specific brand and model.
Yep. Manufacturer, brand, model number, the whole deal. The example was floor tiles to be Contempo, manufactured by Kentile Corp. No question what's required there.
Okay, so describe it, say what it does, point to a standard, or just name the product. Covers most bases, I guess. Now, this ties into organization. Our sources talk about the history here and the Construction Specifications Institute, CSI. Sounds like they brought order to chaos.
They really did. Before CSI got involved, back around the mid-20th century, how specs were written and organized was all over the place.
No consistency.
Very little. Different firms, different writers, different systems. It led to confusion, mistakes, wasted time. So CSI formed in 1948 basically to fix that, to bring some standardization and best practices.
And their big contribution was master format.
That's arguably their biggest legacy, yes. Master format. Think of it like the Dewey Decimal System, but for construction.
Okay, a classification system.
Exactly. It's a standardized way to organize all construction information using numbers and titles in a hierarchy. It creates a common language, so everyone, designers, contractors, suppliers, knows where to find information about, say, concrete or doors or electrical work.
How is it structured? You said hierarchy.
Yeah. It starts broad with groups, then unnumbered subgroups. Then you get into the numbered stuff. Divisions are level 1. Then divisions are broken down into numbered titles, level 2, level 3, sometimes even level 4 with decimals for really specific things.
Drilling down. Okay. The sources mentioned 2 main groups.
Right. First is the procurement and contracting requirements group. That's Division 00.
Division 00.
Yep. It covers all the front-end stuff, bidding info, instructions to bidders, the agreement forms, contract conditions, basically all the paperwork before you actually start building.
The administrative and legal setup. Got it. And the second group.
That's the specifications group. This holds all the technical specs, Division 01 through 49 currently, I believe. And this group is organized by those subgroups, things like general requirements, facility construction.
Which would have concrete, masonry, metal.
Exactly. Then facility services. That's your MEP systems, mechanical, electrical, plumbing. Site and infrastructure for exterior work, process equipment for industrial stuff.
So if I need info on HVAC, I know to look in the facility services subgroup, Division 23.
You got it. Division 23 is always HVAC. Division 08 is always openings, doors, windows. Division 09 is finishes, paint, flooring. That consistency is huge.
I bet. It saves so much time just knowing Division 08 has the window specs, project after project. Can you walk through finding something specific, like those wood doors?
Sure. You'd go to the facility construction subgroup, find Division 08 openings. Inside that, you'd find a level 2 title, maybe wood doors, numbered 08, 14, 16.
Okay.
in more detail. Maybe you're looking specifically for flush wood doors. That could be a level 3 title under wood doors like 08, 14, 16.
So the numbers get longer as you get more specific. What about the metal window example? Still Division 08.
Still Division 08 openings. Maybe level 2 is metal windows 08510. Then level 3 differentiates. Steel windows might be 0850123. Aluminum windows 0850113.
And you could go even deeper.
Oh yeah. Hot rolled steel windows, that might be level 4, like 0850123.13. It gets very granular.
Wow. Okay. And asphalt paving, different division entirely.
Right, that's site work. So you'd look in the site and infrastructure subgroup, find Division 32, exterior improvements. Then maybe level 2, flexible paving, 3212 scissor. Level 3, asphalt paving, 321216. And again, level 4 for specific types like road mix asphalt paving, 321216.16.
It's a really powerful system. Seems like everyone must use it.
It's very widely adopted, yeah.
Yeah.
Not just in specs, but cost databases, product literature. It's pretty much the industry standard framework.
Now, something that sounds confusing. General conditions versus general requirements. They sound almost the same.
Ah, yes. Crucial difference. Easy to mix up.
So what's the deal?
General conditions are part of the contract, the legal agreement. They set out the rules of the game rights, responsibilities of the owner, contractor, architect. Things like payments, changes, insurance, disputes, big picture legal stuff.
Okay, contract level, legal framework.
Right. General requirements, on the other hand, are part of the specifications themselves. They live in Division 01 of master format.
Division 01, got it.
And they deal with the operational administrative side of the actual job site. Things like project coordination, how to handle submittals, quality control procedures on site, temporary utilities, site cleanup, safety rules, more procedural, day-to-day stuff related to doing the work.
So conditions, contract rules, requirements, on-site procedures in Spec Division 01. That helps.
Exactly. And speaking of structure within the specs, CSI didn't stop with master format. They also developed section format.
Okay, so master format organizes the subjects, like finding the asphalt paving section, 321216. What does section format do?
Section format standardizes the layout of information within that section. So once you're in 321216, section format provides a consistent template for where to find specific details about asphalt paving.
Ah, so it dictates the internal structure of each spec section.
Precisely. It ensures that information like field conditions, quality standards, reference standards, mix designs, installation instructions, all that stuff, is always presented in the same order, in the same place, regardless of which section you're looking at.
Consistency again. So what's the structure?
It's a 3-part structure. Part 1, general. This covers the administrative stuff for that specific section-related submittal requirements, specific QA for that work, warranties, things like that.
Okay, the admin for that specific item.
Part 2, products. This is where you find all the details about the actual materials, what they are, acceptable manufacturers, material properties, maybe sustainability info, fabrication requirements.
But what you're actually using. And part 3.
Part 3, execution. This covers everything about installation, site preparation, how to actually install it, testing, cleaning, protecting the finished work. The how-to part.
General, products, execution. Makes sense. The sources had an example. A sub looking for base coat aggregate info for that asphalt paving. Section format helps how?
Because of section format, that sub knows material details like aggregate type will always be in Part 2, products of Section 321216.
They don't have to hunt through the whole section?
Nope. Need installation steps. Look in Part 3, execution. It makes finding specific info much faster and more reliable.
That standardization, both master format for the big picture and section format for the details within, seems incredibly valuable.
Oh, it is. Huge time saver, reduces errors. And as the sources note, these CSI standards are very widely accepted across the industry, professionals, companies, government agencies.
Okay, so we have these great systems. But life isn't perfect. Our sources admit conflicts can still happen between drawings and specs, right? Human error, complexity.
It definitely happens. Despite best efforts, you might find the drawings show, say, vinyl windows, but the spec section for windows calls for wood.
Or the roof tile example, a Spanish tile on the drawings, concrete tile in the specs. What gives then? Is there a rule like specs always win?
Wouldn't that be simple? But no, there's no universal rule like that. Sometimes the detail level dictates a very specific drawing might override a vague spec note or vice versa.
So it depends.
It can. Often, though, the contract itself, usually in the general conditions, will state an order of precedence. It might say, in case of conflict, specifications govern over drawings, or the other way around.
Ah, so the contract might pre-solve the argument. What if it doesn't?
Then it often falls to the architect or engineer as the designer and interpreter of the documents to make the call. They have to look at both, consider the overall design intent, and make a fair determination.
Which could impact time and money, obviously.
Absolutely. Resolving conflicts always carries that risk, which is why getting it right the first time is so important.
Which leads back to that industry saying the sources mentioned.
Exactly. Say it once and say it in the right place. Avoid putting the same info in multiple spots where it could contradict, and make sure it's clear and accurate where it does belong. That minimizes the chance of conflict.
Makes perfect sense. So wrapping up, it's clear the specs are far more than just footnotes to the drawings. They are the crucial definition of quality, materials, and methods.
Absolutely indispensable. Drawings give you the geometry, the quantity. Specs give you the substance, the quality.
And understanding these organizational systems, master format for the overall structure, section format for the section layout is really essential for anyone working with these documents, wouldn't you say?
Essential. It's the language of construction documentation. Knowing how to navigate it efficiently is key to avoiding mistakes and building successfully.
Definitely. So here's a final thought for you listening. Knowing how complex these projects are and that conflicts can still happen despite good systems, what other proactive steps or maybe even technologies do you think could be used right from the start of a project to help minimize these kinds of discrepancies even further? Something to chew on. Thanks for taking this deep dive with us.